So today we are going to learn about the forecasting. So when it's come to forecasting, it's not only for weather forecasting, but also it can be applied for any other forecasting model. It can be a stock market forecasting, cryptocurrency forecasting, or any other forecasting model, right? Basically, the same concept can be applied. So here today we are going to learn about the weather forecasting, and we are going to use the humidity data to do the prediction, right? So we are going to train using a past historical data, and we are trying to predict the future humidity data over here. So that is what we are going to do. So this weather forecasting is very important when it's come to power applications, right? Because in Sri Lanka only we have the luxury fixed tariff system, right? The home owners, they don't just feel the variable tariff system, they pay per unit charge, right? For certain unit charge this much amount. If you exceed 90 units or something, there is another tariff like that, unit wise charge. So that's actually cheaper for us, right? Cheaper in a way we don't want to care about when we are using the energy. But in other countries, the energy charges varies based on the energy production cost. For example, in Australia, every 15 minutes, the energy charges varies. So, for example, if the demand is high and the generation is low, what they do is they increase the energy cost, right? So, by increasing the energy cost, many people shut down the lights during certain time, right? So, one of my friend had a shop in UK. He was saying like during the peak hours, they shut down all the lights in the shop, grocery shop, because the energy cost is really high during the peak hours. So what they shut down the thing. If a customer comes, they go with the torchlight and get the stuff, right? So that much high costs are applied during the peak hours to reduce the consumption, right? So when it's come to the price, they can't say, okay, this will be the price immediately. Okay, now what's the time? 9:48, right? They can't say 9:55, this will be the charge. They should announce the charges earlier too, right? This will be the charges for this day. So then only you can plan. So, for example, if you are predicting the weather, the sunlight irradiance, that is very correlation with the solar energy production, right? So the solar energy production cost is very, very low compared to other production cost. So when the solar energy in surplus, what they do is they reduce the cost. So to reduce the cost, what they need to do, they need to know how much radiance level will be there tomorrow. Oh, every 15 minutes, I need to see, okay, what will be the generation I will get through this in this hour, in from this place. So like that, they have to do the planning, right? Demand generation planning, right? So to do that, they have to forecast the sunlight and weather and everything effectively, right? So then what they do, okay, based on the weather forecasting condition, they can estimate the solar energy output. Then they plan their schedule. So let's say if the solar energy going down due to a cloud movement, right? Then the certain energy production from the solar output is going to be very less. So they have to start another generator in order to supply the power to meet the demand, or else they have to increase the cost to reduce the demand. So they do in both ways, right? So it depends. If is the raining solar production is completely zero, I think they will increase the cost, or else they will try to reduce the demand. So it's a scheduling task. So in that application, the solar forecasting is very, very important. At the same time, the demand forecasting also. Demand forecasting mean what? How many people are going to use this much amount of power usage per day with the hour, right? Minutes, power usage. So they can estimate the demand. So usually our demand is more or less is a flat. There is a peak in around 6 to 9 p.m. due to the night time, then again comes down, right? More or less flat, flat demand structure. There is not much variation. But in other countries, the variation is high. Why? Because they have four seasons. We have one season, like one or two, rainy or not rainy, right? They are sunny, spring, summer, autumn, like there are multiple seasons. So during the seasons, the weather also varies and the demand also varies, right? So everything need to be forecasted. One application is this one. And the forecasting application, the hotel project, right? So I was talking about we were forecasting the revenue for next month, right? So based on the input that we provide, we will be able to forecast the revenue that we can make from a hotel. So based on that, the hotel people schedule and manage the stock. Let's say next week you are going to have a peak revenue. That means many people are going to come to your hotel, right? Due to certain reason. Then you can keep the stock to serve those people and allocate the manpower. Okay, the demand shows high. So therefore, I want to have much more manpowers in my hotel to serve the people. So like that, they manage the hotel. So in hotels, usually there will be fixed staff and there will be contract staff, right? So fixed staff mean they will be always there. Contract staff mean on demand they hire the people. They okay, I need 10 people today. Then the agency supply with 10 people to serve the hotel. So that kind of setup is there because they don't want to pay every day for them. Only for that day they have to pay. So they manage a lot of amount saving due to that scenario. So they wanted to know how much people will come to my hotel and how many staff requirement I need. So that also we have predicted, right, in the hotel application. So it was a super cool thing. So another thing, you are working on the cryptocurrency something, right? Prediction. So those are the things. So today as a basic, we are going to learn about a small forecasting of a humidity value based on the past historical data, right? So only one data point we are going to use. Based on the past historical data, we are going to predict the next hour humidity value. There is hourly humidity value we have recorded, right? So that's the data that we are going to use. But actually, when it's come to cryptocurrency or many other application forecasting, you cannot only rely on past input of one data because the cryptocurrency past data, if you consider and if you rely on completely the past amount of data and you are going to predict the next value, you might fail because cryptocurrency value depends on the week of the day, right? Which day is it? Which month is it? And what is the economical condition of the country, political scenario? Everything matters. So you have to input all these value as an input to the neural network to learn and predict the next value. For example, the hotel thing, the input is the day week, like, okay, day of the week. That means it's a Monday or Tuesday, Wednesday or Thursday or Friday, whatever. And week of the month, first week or second week or third week or fourth week. And month of the year, which year is that? Is it a holiday or not? Right? And the input other data is past revenue data, right? And any event, special occasion happening in that area. And even the weather, we took the weather data also, right? And item wise sale. So we put a lot of data as an input to predict the revenue for the next week or next day. So how we select the data? Okay, these data are like basically going to be the inputs for the model. There is something called correlation analysis, right? So you check, you are going to predict the revenue and you have tons of inputs like day of the week of the month, all these stuff on top of that, past revenue, historical data, past sales, past guest numbers and everything, right? So what you do is you analyze the output, that means the revenue, the correlation with the other inputs, and you select the best correlation values and correlation value columns and you select that as an input to train the thing. So in this case, we are not going to do that because we are going to use only one column to predict in the past, only one input. But if you are going to have multiple inputs, you have to do that thing. For example, when we do the energy forecasting, that means solar energy generation forecasting, we consider the temperature input, humidity, and there is a thing called cloud movement, right? Scenario plus raining or not, 1 or 0, right? So all these four inputs with the energy production past historical data. So we have the past historical data, temperature, past historical data, humidity, past historical data of raining or not, past historical data of cloud movement, and the solar energy past historical data. So we know when this day, this rain, this is the temperature, this is the humidity, this is the cloud movement scenario, this is the output. So in the second hour, this is the scenario. So we have the values for all the columns. So these are the inputs and this is the output that we are going to predict, right? So first, the correlation analysis is very important to do the multi-column input and prediction of one value out. So that need to be done in the thing. So when it's come to cryptocurrency, what are the inputs that you are taking? That's not going to be enough, right? That is exactly going to match what we are going to do today, right? But you should consider the other scenario. Maybe week of the which day is it? Is it Monday means 0, 1, 2, 3, 4, 5, 6 like that? You can label Monday, Tuesday like that. That's an input. And check the correlation with the data. Sometimes it's come down, Monday goes up, Monday goes up. There's a scenario everyone says. Tuesday evening and Thursday evening, if you check and book a flight, that might go low. The prices go low on Tuesdays and Thursdays. I have observed that. I have observed that scenario in the flight booking thing. If you want to book a flight, try to book the flight in Tuesday nights and Thursday nights. The price goes low. That means there is a correlation with the week of the day, right? What week? Is it the second day, Thursday, Wednesday, or Tuesday or Thursday? So, like that, crypto also might have something. So, what you have to do is you have to collect all these data, week of the day, which month is that, which country, political stability or not. Stability means you can put 1, unstable means 0, or else you can rate the stability within 1 to 10. 0 means stable, 10 means unstable. Now, actually, that is going to affect Sri Lankan election, is going to affect the stock market price in Sri Lanka. Every company is now trying to go into public domain. You know, LTL is going to come into public domain. Why? Because they are scared their stock values might go low. So they want to come public and sell as much as possible before 2028, where we have to pay the loan. Right? 2029, I think by 29, we should have paid $28 billion. That means within these 3 years, we have to make $28 billion. So that means we are already $10 billion in debt every year budget. So we have to earn that 10 billion. On top of that, we have to generate 28 billion within these 3-4 years of time. Right? How is it possible? I don't know. So that's why many companies are thinking about selling and coming into the public domain. If you see LTL is coming public, many other companies coming public to sell their shares because they are anticipating the dollar value is going to go high and they are going to get messed up. So they want to develop their company within this short period of time to sustain the effect that we are going to face after 2029. So all these things matter. So past value only not going to be enough. So you have to check what are the correlated values, right? So try it out and put all the inputs and print the out. Okay. So now we will move into today's lesson. So how we can make the prediction. Okay. So now I am going to do something. Okay. So we have a value here. We have a value. Can you predict the next value? Let's say this is the humidity and this is our first hour. Can you predict the next value? Can you predict the humidity now? Third one. What's the humidity? Yeah, because I have 2 points down to this. You can say somewhere around 10, but it's not sure. It can go high also. So we can say either here it's going to be here. Let's say now you determine as predictor, stay here. Can you predict the fourth? Yes. So that means when past history value, you will be percentage. For example, if I'm going to draw this thing. the trend of a certain thing. Now tell me what will be the next value? Is it going up or down? Down. But can go upwards? We don't know, right? So that means how many data that we are going to look at while you are doing the predictions. Tell me one, when you have 10 size, 20 size, and you can say, in the past 20 hours, this is the thing. Yesterday, past 20 hours also, this had happened. So maybe 21st hour, this might be the day. So like that, you can do the prediction. Human can check it, right? Based on the trend, we can say this might be going lower. That's how the traders do manually, right? They have trained their neurons, brain neurons in such a way to understand the data trend, right? And they also do some statistical analysis. So they do moving average, they do average and take the next interpolation and find the next value. A lot of methods are there, right? The best thing is to look back and let the AI do the work. Still, there are issues, right? That's instabilities in certain domains can affect a lot. This COVID, whoever expected? Nobody expected COVID. Hotel revenue went really bad during that time. So we were looking at the data from 2009. They didn't make a single penny as a profit. They were running on loss in Dubai, the hotels, right? So nobody expected. So, but if you use the training model that we have used now, it won't predict that because that scenario is not added into that model, right? So the way you take the input is very important. Therefore, go back and analyze the correlation. What are the key parameters affects the cryptocurrency thing? Definitely American politics. Similarly, there are multiple options you can look for. So after identifying these correlation values, that means what are the parameters correlating with the output, then we select that as an input and do that. Okay. So when it's come to weather forecasting, first of all, we need to have the data collection. Whatever the forecasting, past historical data collection and the correlated value data collection is important. And data pre-processing. When you collect the data, these data we are getting through the sensors, right? You are not going and manually doing it. It's automatically collecting through the sensors. Sensors have an issue. Sometimes it might give a wrong value. Sometimes it might not give any value, right? So there are possibilities. So in most of the data, when you start to collect past 3 years, 5 years, 10 years data, you might find it out certain values are zero or none. That means there is no value recorded during that time. So you will encounter a lot of trouble during that thing. So in that case, what we do is either we cancel that one or else we replace the none value with the previous value. Or else we take the none value, previous value, next value, and the average of that goes to the none value. So there are multiple options we can do. So that comes under data pre-processing, eliminating the null values, replacing the null values, and we have to make sure the data is clear, right? If the data is not clear in the middle, then you cannot even do the prediction. So we have to make sure the machine learning do that. Feature engineering means that is something when it's come to the these predictions, anomaly detection, right? For example, we gave the input, we did a model to predict the anomalies in generator bearings, right? So the input data were vibration data, temperature data, RPM and everything. So we tried initially with giving the vibration data as it is, right? It was not that efficient. Vibration value versus the time. So time versus vibration value. That was not effective. So we did some feature engineering. So we extracted the vibration frequency. Rather than giving the vibration value, we get the frequency of vibration, right? And we take the peak and put it there. So like that, you separately analyze certain features. You don't give to AI, right? You say, okay, you analyze and you find out, okay, this feature is somewhat varying when the bearing vibration is varying. So I will, rather than giving the vibration directly, I will extract the feature and put this feature as an input to the AI model. Then it will learn quickly. It will learn. Otherwise, you have to do a lot of training, and you sometimes when you do overtraining, the overfitting might happen. So always it's better to create the feature engineering before you tell the model. But due to the deep learning, we don't want to do that because automatically it's going to learn. But still, it might take a lot of iteration. Sometime it might go overfitting as well, right? So therefore, feature engineering and data splitting, we know for training and testing, model selection, what type of model that we are going to go for. So when it's come to the model forecasting, up to now, the RNN models are the best, right? Recurrent neural network. Recurrent neural network means it's going to keep a certain memory in the past, and LSTM. Here you can see the LSTM, long short-term memory. In my experience, up to now, LSTM is the best, right? Or LSTM is an RNN architecture, recurrent neural network architecture, or else there are GRU model, BiGRU, BiLSTM, pure RNN model. So there are multiple things. But if is it an RNN based model, that is the best for forecasting. What you are using now? Okay, so try LSTM. That's gave the best results out of many models that we have encountered for the hotel project. Okay. And model training after that, model evaluation, forecasting, then we update and retrain. Why we need to update and train? So if I, in the hotel project, what happens? So I predict for next week and I make the decisions and everything based on the prediction. Then if I want to predict the week after next, I input the recorded data for next week, actual data, and do the retraining and predict for the next week. So you have to do the training every time. This is not only one model, you put the past historical data and going to do. You have to train it, predict, and take the action. Then actual data goes as an input, and you do the training again, then do the prediction. So then the model will learn, and do a better prediction modeling. Okay. Right. So that's what we do every month in hotel. We collect the date and we train and we predict for next 3 months. So once the month is over, we collect and do that. Then the hotel people said the month prediction is not good enough, means they want every week prediction. So they started to train every week. Collect the data, train, collect the data, train, predict, like that. Okay. Okay. So now we are going into the weather prediction using neural network data set. So the data set we are going to download from this website, Kaggle. So go there and download the data set. Just click download. Once you download, you will ask for login. You know, earlier we had created the login details. So you can download that one. There's a link, right? Open up the link and go and download. Then extract. Or else you know how to get these things directly also from Kaggle using the Kaggle key, right? So I just, now we are going to update the humidity, pressure, and temperature. Okay. These 3 data, I'm going to put it into the Google Colab. Maybe humidity, what other values I am using? Humidity, pressure, and temperature. Yeah. Humidity, pressure, and temperature. I'm going to just load this one and put it over here. Right? Drag and drop. That's all. So once this is dragged and dropped, now we are ready to move on to the coding session. So we got the data. Let's open up one data, maybe the humidity data that we are going to work with. It's as a Excel file, right? You can see the date and time, and the area, San Francisco, Seattle, Los Angeles. See, right? All the certain states values are here, right? So here, if you see, there are certain values not recorded over here. Can you see it? These are called none values or null values. So because it's recorded through sensors, sensor packages might be missed. So in that case, the data might not be recorded, right? This is a common issue when it's come to data engineering. So what we do basically, if it's 66, two values are missing, either we fill it with 66, 66 or take an average and put it here, right? Here 1, 2, 3, 4, 5, 6 values are missing, but you can fill it with 48 or else do some manipulation and get the data, fill it out over here. So you can't keep it null because null value means how the AI will predict. So you should give the value to the AI. So similarly, you can see a lot of columns missing data. See, this column is really bad here. So it's a lot of missing data for Montreal, right? So Pittsburgh, Chicago. So these are the values. So basically we have the date and time, right? This is the date, 12, 12, 13, 14. It's in the 24-hour time scale, right? Every hour they have recorded the humidity value. So this is the data that we are going to use over here. Okay. So I have successfully uploaded. Now we will start. We will import the library that we want to work with, the matplot library, because we are going to plot multiple graph and see, right? Then after that, I'm going to import the pandas as PD. Why? Do you remember we use something called pandas in the third class? Why? Because when we are working with column type of data, right? To structure the data and work with that data, panda is easy. Otherwise, if you without panda, you are going to have a hard time. So numpy as np, that's of course without that you can't do any mathematical operation. Pyplot done, and more chain set option. So like this is a, how to say, I'll come to that, right? Pandas, I'm going to set PD set option means PD is the pandas, set option mode dot chain assign. So right. Okay. So in the Keras model, because I need to build a new sequential layer, I'm importing dense layers and I'm going to use the optimizer for RMS prop. So you can change the optimizers as you want while doing the training. So I'm importing those function over here. Do the work. Okay. Once we import, first thing, as I said, we have to do the data pre-processing, data cleansing, and data reduction sometime. So usually what will happen is in certain vibration recording, we have recorded the data for every 20 milliseconds. So for 1 minute, 1 second, there are a lot of data available. So if you want to predict in millisecond, human doesn't work in millisecond range. So if you predict whether it's anomaly or not within 5 seconds, that's enough for me. So I resample the data. So that means the recorded data is every 20 millisecond. So that you can imagine for every second how much data you will have, right? So what I did was I resample the data and get every second data, 1 second, 1 second, right? Every second data. Even it's loaded the model because you are going to have tons of data for the training. So the training going to take a long time. So I reduce it to 5 seconds. So every 5 seconds, one vibration data is recorded, right? So then we did the thing. So that is called data reduction. So earlier I had 20 millisecond data sampling rate, now 5 seconds. So I'm reducing the number of data for the training based on my application. So do you need every millisecond data for the cryptocurrency? No way, right? Maybe every hour or every half an hour should be more than enough, right? So therefore predicting every millisecond is not going to be worthful and you are going to load the model. It might learn in a bad way. So that's why we have to do the data reduction. And data transformation, as I said, it's a feature engineering. From the time domain to frequency domain, we have done the vibration, right? So in certain application that is important, and data enrichment and data validation. So now we will load the data set and we will check the data information. We will handle the missing values, visualize the data set and finding anomalies in the data set. And certain places, I'll come to that thing. So once you uploaded these data, we will load all these data into the platform and let's plot and see the humidity value, the first 5 columns. So once it first columns, you can see the first value is completely none. There is no value recorded. In certain places, certain missing values are there. So now the problem over here is finding the anomalies in the data set. So what is the range of humidity usually should be? Usually 0 means there is no water molecules in the air. So that is very rare, right? So 30, 40 is a very low humidity. 100 means it's water, fully water, right? So you are in a water mean 100 humidity. So 0 means maybe inside an hour, there is no humidity, right? So both is extreme conditions. So certain cases in data recording, we are recording through sensors. Sensor is another device, right? In certain cases, you might get some values above 100 also. It's a sensor error. It's giving 101. It cannot be 101, right? But it's gave 101 means it's an anomaly. So you have to identify that also. These are data engineering. So there is a position in many companies, hotels. One guy I work with, his name is Sohail, right? So he's a data engineer, data scientist. His part is to do the data analysis and reduce the anomalies and feature the data, and he also do the prediction in using statistical method and everything. Now work with him and build up this model to reduce his workload. Earlier he sit and do for a long time. Now he just upload the data, it will do the prediction, right? So that's the thing. So now let's print the columns. What are the columns in the humidity data? So you can see Vancouver, Portland, San Francisco, Seattle, Los Angeles, San Diego, Las Vegas, all the US states are there. And Jerusalem, some other places also there, right? Okay. So now what we will do, we will select one city, Portland city. So I'll go open up the Portland city in the humidity data. We'll find out the Portland city and see the data, how it looks like. Portland, 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 Portland. Here we go, Portland. So if you come down in this column, right? In this column, if you come down, there is an n value, right? There is an n value. Come down in the Portland column. There are one n value, one n value, one, 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 two, one. So you can see certain data points are missing, right? So it's not a 100% accurate data. 100 is there, but in certain cases we'll see whether we have any max. We'll find out the max. Okay, here in the Portland column, this is the Portland. All right, this is the Portland column. So let's say I'm going to say the max. Hmm. 86 is the max. Ah, no, cannot be. Give me a second. See this number, right? 45254. 100 is the max. So that means data is okay. We don't want to worry too much about that. But sometime the data might go to 101, 102 due to the sensor errors. So in that case, we have to replace that 101, 102 to 100 as maximum. These are pre-processing and assumption that we make. Okay. So I'm going to take the Portland data over here. Then I'm going to extract the Portland data and the date and time. So the date and time is the input and the Portland data out is going to be the output. So first 10 we will load and print it out. So you can see this is the humidity value of the Portland value. This is the date and time. These are the number of columns that over here. So let's print the last rows and see. So you can see these are the last rows of last 10 rows over here of the humidity, Portland value humidity, and do that. So now how many shapes? What's the shape? So we have 45,253 rows and 2 columns. What are the 2 columns? Portland humidity is 1 column. Date and time is the another column. So we have 2 columns and 45253 2. So now the next part, what we are going to do is we are going to get the how many null values are there in 45253 data set, right? So if you check it out, So 449 non-values are there in that column. So that is around 1% of total, 0.99 of total column values, right? So now what we need to do, we need to replace these values with some values, non-values with some value. Either you can replace 0, but you are going to put a thing. So it cannot be 78 humidity and another value is none, other value is 76 means it cannot be 78, 0, 76. It cannot be, right? It should be somewhere in the middle. Either the previous value you replace or the next value you replace or take the average and replace. That's up to the data engineer. The data engineer should look like the other trend. So if I go back to this one and open up the humidity Portland value, 80, 80, 80. See, these 3 hours values are 80, 80, 80, the same values. 79, 79, same value. 78, 78, 70. Not much variation. So I can either replace the previous value, that's fine for me, right? And all these things are full numbers. All these things are full numbers, not a decimal point numbers, right? So therefore, what I'm going to do here in this case, I'm going to replace, you can take the median, you can take the lot of things, right? Nearest. So that's up to you. Based on the feature engineering, data engineering, when you look at the data, previous 2 data and what are the 2 data next, you can see a trend. So you can decide whether to replace the data with the previous data or take the interpolation and find the middle value or take the average and up and down and put it there. That's all up to the data engineering based on the data structure, right? So here, since it has the same thing, what I'm going to do is I'm going to refill the data with the previous values. If it's in a misvalue, I'm going to take the previous value, put it there. And I'm going to keep on going. And if the null value is found out, I'm going to take the previous value and fill that null value, right? So that's what I'm going to do here. Missing value with previously available value, right? So used to remove rows containing missing values after applying the fill. So then now I'm going to check the shape 45252, the same thing 45253. So there is one thing is removed here. The data total column values loaded here. If you see 45253 and columns 2. So here when I after removing the non values and filling the non values 45252 2 1 is eliminated. Why? What's the reason? Because in this Excel file, I'm saying fill the non values with the previous value. I come down in the Portland, I found it, I put the 25 here, right? I come down, I found the non value, okay, I put the 37 here, right? And I come down, I put the 29 here because 29 is the previous value. I like that I fill all the non values, but when I come here, what is the value I should put? Here also there is a non value. So there is no value. After filling in also, it's none, right? So therefore, I'm deleting this value now, right? That's why one row is completely eliminated. So that's why we got 252. Clear? Right. So after that, I'm going to print number of values San Francisco column. Okay. So for example, to check the humidity value in San Francisco. So no, sorry, not in the San Francisco, Portland, right? What is the city that we are going to use? Portland city, am I right? Yeah, Portland. Yeah. So after filling it, okay, how many nuns available? Nothing. So there is no data because I filled everything with the previous value in this point, right? In this point, I filled it. So when I check it after filling it out, there is nothing available. So that means we are good to go. All the columns has, all the rows has values, right? So now plot and see a couple of points. This is how the first 1,000 points are going to look like, right? You can see the variation of the humidity values, how it has varied, right? How it has varied. And in certain places, what I need to do is sometimes the value might be 100, but in our case, it was not 100. So anyway, we have to find out the maximum. And what I'm going to do is I'm going to replace, if is it x is greater than 100, replace it with 100, right? Or else put the same value as x. I'm going through the rows and finding out whether it's 100 or greater than 100. If it is greater than 100, I'm going to replace that greater than 100 value to 100. So this is what I'm going to do. In our case, there is nothing because the max value is 100, right? So in certain cases, the values can go above 100 also, right? So those are data anomalies. Data anomalies. So we call those as outliers sometimes. The outliers are a huge problem in data analysis, right? Everything is going nice. All of a sudden you see a spike, right? But it doesn't make any sense, like going down, down, down in the downtrend. All of a sudden there is a point up over there and again come down, come down, come down, come down. Do you think that's a standard data or something? Might be. But most of the time, if we see some spikes over there, we neglect that as an outliers, right? You have heard about outliers, right? So it's which not come under a certain pattern areas, right? There are certain data like chunk, these outside things called outliers. So we remove the outliers also in that case. We remove the outlier columns completely, right? All right, remove it and put the average value. So that's up to the data processing engineer. So now after data is ready with removing the null values and replacing with the previous value, at the same time, I replace the above 100 values to 100, right? Now I'm going to do the splitting of the data, which is going to be 1500, right? I'm sorry, 15,000. I'm going to use 15,000 data in this case for the training, and the rest of the data, which is going to be 30,252 because we have 45,252, right? So for the testing. So let's separate the data. First 1,000, and I'm going to check the test data and train data. So the test data is going to be this much and train data is going to be this much. Okay. So after that, reshape the train array. So what we need to do? So we have split the data. What is the next step that we should do? We have to normalize the data, right? Always we normalize the data. So I am reshaping the data to come into the normalization by -1 and 1. So basically it will map to this train reshape thing. So after that, this is the shape of the train shape data set 15,001, and this is going to be 30,000, and these are the testing data set that I'm going to use. Okay. So first we'll check the points over here, 81, 80. These are the 10 points over there, right? So now let's plot the test data and the train data together. Here the blue color data is the test data that we are going to use. So train data that we are going to use. And we are going to test on this yellow color data because we need to do the training and we have to test whether we are predicting accurately or not, right? That is very important. So what we do is training and testing. So every time we use the hotel training part, we train the model and we keep the last week for the testing and we do the prediction on that last week before the week and we test the accuracy. If it's predicted above 80, 90, then it's a good training actually, right? So, and also we do the model stopping at the early stopping. Early stopping means what? When the loss value is going down, going down, going down and it started to increase, then we stop at that point, right? So we keep on training. The loss value is coming down, coming down, coming down, coming down. But all of a sudden it's going up. Then second also going up. Third also going up means we found the minimum value, right? Then what it will do is it will save this model, lowest model. So that is the stop at the early stopping, right? Or else we keep on saving until the thing, all the model, and finally we select the last one. So that's up to the training thing. Early stopping is better. You can reduce the time because you know how long does it take to train for the hotel. Can you imagine? We have 16 GB RAM, sorry, 32 GB RAM, and the hard disk piece is like a lot enough, more than enough. And GPU is 4 GB, A0, A10 or something. With that, it takes nearly 8 to 12 hours for training, right? If you are doing the early stopping, with the early stopping, 8 to 10. Without early stopping, if you go for 100 iterations, it's going to take a lot of time for you, right? Because it's a large model. There are a lot of inputs that we have put in, right? So the inputs are more than 3,000 columns because they wanted us to predict the item-wise sale also. Item-wise sale mean what? So they want to know next week how many Coca-Cola bottles will be sold. That is item-wise sale. So if you only need the revenue, we don't care about the other stuff. We just take about the day of the week of the month, any other special events, holidays, and the past historical data and everything. But now they want revenue and they want to predict how many item will be sold. Item wise, Coca-Cola, how many salad I will sold, how many this much thing I will. So those are not necessary for them, but they wanted it. So in that case, we created the model really complex. So we have more than 3,000 columns as an input data to predict item wise thing. So it's a crazy model, right? So, but in this case, it's easy for us. For your thing also, maybe maximum 3 or 4 inputs going to be there in the snake. So these are the testing data, orange color. Training data is going to be blue color, 15,000, 35,000 and 252. So RNN model requires a step value that contains n number of elements as an input sequence. As I said, RNN model look back the data and predict the next. So we call it as window size or step size. Whatever the RNN model you take, LSTM, that's an architecture. GRU, it's an RNN based architecture. And typical RNN, it's an RNN, right? So we need to define the step size. So how many data points you take in and you are going to predict the next value, right? And how many data points that you are going to look back and predict the next value. If you are taking the 10 as a look back value or set value, so you are going to look back the past 10 data and you are going to predict the 11 data, right? As a batch 10, predict 11. Batch 10, predict 11. Then it's move and then it's move. The training is going to have 8 size. 8 inputs, predict the next one. 8 inputs, predict the next one. 8 inputs, predict the next one. You get it, right? So it's going to keep on moving one by one. One by one. If you have 10 data, right? And the 5 is the window size, what will happen is, while training, you'll take the first 5 input, predict the 6th out, and check the error. And move 1 ahead, and 2 to 6, it take the input, predict the 7. And move 3 to 7, predict the 8. Like that, the training is going to happen as a window size. That's what the benefit of RNN. If you use simple neural network, you input the data, it predict the next value, but it's not going to look back. So the set point is important. So the set point or set value or step value going to have a huge impact. So how to find the right exact step value for the prediction? Any other mechanism that you have? No. Trial and error. So what we have done, we have automated the code loop for training and testing, and we set the step size to 2 to 20, right? And we ran the model for 3 days. So the training happened for every step size, and we tested the accuracy with the test data, and we found out the step size 10 is the best results we got. So that's how we selected the 10, right? For the hotel project. Similarly, you have to do that testing. Change the step size and check the output with the test data. And you will find the output results, right? The accuracy. So then you select the step size for this particular data set. 10 is the best step size, or 8 is the step size, 20 is the step size. It's okay, right? So it's going to vary based on the data's type, right? What type of data variation you have. For this scenario, I'm going to take the step size of 8, right? So the step is equal to 8. We will check by varying the step size, okay? So I'm going to start, let's say number 2. That means what I'm going to happen. We'll start with number 2, right? And we will see how the accuracy varies. Step number 2 means I'm going to look 2 data and predict the third one, right? That's not enough. You cannot look at that, predict the 2 and it might be wrong. So let's see how the neural network plays. Okay, I'm going to play this one. Set the data to thing. And now I'm going to train and test data. and we know these are the elements, right? Because 2, what this 2, 15,002 is going to be there. If I put the 8, this 10, right? What is happening? I'm messing it up, right? 12. So I should have not done it. Okay, anyway, let's keep the step 2 size. Okay, what happened is it's shifting the column. It's shifting the column because I need to look back. So that means the uh, Portland humidity data is there. So I'm going to look back the last 2 and predict the third means. So for last 2 input, this need to be shifted by 2. So that's what happened, right? That's why the column value is getting over here. So after that, I'm going to change the step size to 2 here, and I'm going to do the training, right? And okay, train the step size. I set that step size to 2. Earlier it was 8. So I'm going to check the size now. So this is the size, and let's do the training. So let's take the training for maybe yeah. So these are normalization, right? We need to divide by 100. I'm dividing it everything by 100 to do the normalization part. Then this is the data size of mine, 2. Then I'm going to build the RNN model. So the learning rate also affects, how the learning rate affects, right? Because when you train a model, if the learning rate is higher, what is going to happen? It might miss the global minimum. You take a big step, you train a thing, but sometimes the global minimum might be here. So you miss it. So always the smaller size is better. But if you keep the smaller size, its training is going to take a long time to get to the minimum. So it's also a practical scenario. You have to identify in your data set where might be the global minimum. So that again, trial and error stuff, right? So here I'm going to use the ReLU function. Usually we use the ReLU function most of the time in this class. Then after that, sequential layer, which is going to have a simple RNN network, 128. So if you see the LSTM, somewhere you have to define here. This is simple RNN. So you can, if you want an RNN LSTM architecture, you can define the LSTM in this case. Okay. Then I'm going to add the dense layer 32. And last one is 1. Why is 1? Because I'm going to predict the humidity only. Right? Therefore 1. So the loss is going to be mean squared error. So MSE is the loss that I'm going to compare. So let's build the model. And this is the model summary. Right? So I'm going to do the epochs for maybe 50 or maybe 20 is enough because we are going to check with the step size. Okay, 20 is the thing, batch size 8. Batch size means we know what is batch size. So I'm going to start the training now, right? Right, there is an issue. Yesterday also it happened. Give me a second. There is something we need to change here. Ta-da-ta-da. Yep. Give me a second. Let me update the code. There is a small code tweak we need to do. Okay, let me share my screen. So can you change this code? So yeah. So now earlier you had this model.compile. So model.compile. So here you have to change this in this way, right? LR learning rate. Here you have to change this as learning rate is equal to learning rate, right? That's LR is a old kind of code. So you have to check this one, optimizer RMS prop. So here optimizer RMS prop, learning rate is equal to learning rate and metrics is equal to MSE. That's fine. So this need to be changed. Last one. Other than that, all the code is same, right? So the last part need to be changed like this one. I'll delete this one. I'll run this one again. Only the optimizer is equal to RMS prop. Here you have mentioned LR is equal to learning rate. So you should retype that as learning rate is equal to learning rate. That's all. Is it done? Okay, cool. So once it's done, I'm going to take the model summary and come over here again, define the batch size and everything. Now start the training. It will start the training. Now what I'm doing, look back to and predict the next. It's not going to be accurate according to my understanding. Let's see how the model understands. Okay. If it is not much complex data variation, it might be able to, but if there are much variation, then yeah. Have you done the training? Shall we check the accuracy? Okay. Let's plot the figure training thing. Okay. Loss seems to be going down. So there is no issues. But let's check the predicted value. So these are the actual train value. And let's plot the values here. Okay. When you look at 0.92 and 0.85, this is the upcoming one. So let's check the accuracy, right? Predicted value accuracy. Maybe this should be 2. Right. So 82, this is the one. So when you load the accuracy here, I just want to check that one. Right? Let's check the value. So actually the expected upcoming hour humidity normalized value is 0.8. That means 80. But the predicted upcoming value is 0.82. There is a difference of 0.02. Not bad, right? Even though the step size is 2, it's not that bad, right? So let's plot this one. This is the predicted and test data, right? And this is the actually predicted values. And we will plot together and see how it looks. The predicted versus, because here it should be 2. I have to denormalize by multiplying 100. What is the issue here? Value error. Okay. I have done the value change here. When I added here earlier, but I changed the two. When I change the two step size, here it keep on increasing, right? So now the column size is changed. So the predicted value was the test value. There is a mismatch. So let me run it from the beginning, maybe clear all the output. Okay, I'm going to go from the beginning. It's very quick. So let me run. Come down for the number 2. Okay. Right. So because that when I add 2 and 8, it changed. That's the issue. Loss is not much changing. Started with 0.0112 and this one, yeah, 0.0057. It's not a much complex data. So therefore, the prediction even with the 2 step size seems to be okay, right? So now let's print the stuffs and we will visualize the plot. Yeah, it's predicting 0.8, but actually is 0. Sorry, it should be 0.8, but our predicted value is now, I think, 0.84, right? 84, but 0.04 is different, right? So now these are the test data, these are the predicted data, and let's plot the one. Okay, now you can see the blue color is the true data and the predicted is yellow color. So blue plus yellow, you get a kind of a beige color here, right? So you can see it's not properly predicted well. See, the blue color is over here. It's visually appealing. The blue color is more visually appealing. That means the 2 window size might not be enough, right? So then you go back, change it to 8. Change it to 8 means you have to start from the beginning because it's now if you change, it's going to be 10, right? So start it from the beginning or else clear the output, start it from the beginning and do it, we can see the accuracy comes better. So here, for example, the predicted value here compared to here, its actual value blue. Those are huge different, right? That means the window size is not at all enough. So we'll go back again, do the same thing, edit, clear all outputs and run it from the beginning, right? Then you will be able to, we will increase the step size to 8 and we'll see, right? Okay. Just run quickly. Everything is the same. And don't forget to change the step size to 8 while you are running. I'm going to change the step size to 8 now. And you have to change in certain place the 8 number. Make sure you do it, okay? So now here the step size should be changed to 8. Here also you have to change to 8. Here also you have to change to 8. Then you can play it. And there is one more place we have to change to 8. Share, okay. Run that one, model summary, 8 batch size. Okay, then I'm going to start the training for the batch size 8. Earlier there was an error in the prediction 0.04 for step size 2. Now we will have a look and see how this is going to be. Okay, now the training is done. We go there. We'll plot. There is an issue here. We have to change it to 8, I believe. So that's fine. And the test X should be 8. This should be 8. No, sorry. Right. And the predicted value after the 9th value is 0.52. So now we will see what is the actual value. It's 0.56, right? The actual predicted value. So when we check that one, let's see how much the prediction is coming up. Okay, here it's 5256. Again, the error is 0.04 for the 9 data, but might be only for one data. Let's check the other one. We'll plot and see how it varies. See, it's not at all good. 2 was better than 8. Did you see it? The down value is somehow filled better than the earlier one, but the top one, the blue, is completely visible to me. So that means it's not a good prediction value, right? So yeah, so it's not guaranteed if you have 8 or 10 or something, it will learn based on the thing. There is no guarantee when the step size increases, the model will predict better. So that's why you have to test for multiple steps and identify this accurate step size that you are going to use for the particular thing. So when we tried in for the hotel purpose, we tried from 2 to 20. The 10 gave the best results. So we selected the 10 window size to do the forecast. So now you have seen when I did the 2 size, the value was good, better than the number size 8. Right? You can try with maybe 4, 8, 10, maybe 20 might give a better value. We don't know. Right? Therefore, you have to test and find out the better window size. Typically, we don't go more than 20 because 20 is a huge amount of data. The 21th value might be not depends on the previous 20 value. So it depends on the time. Here, 1 hour data. So therefore, we go for maybe 10 past 8 hours data or 3 hours data or 4 hours, then we can do it. So when you check the quality of the output, let's see, the mean squared error is 0.004. That's not bad, but still the prediction is not that good, right? So you can go ahead and change the prediction value and check that. Have you completed that task, crypto task? Is it done? So what's the step size you use? Okay. So now you have to change and do it, right? Now you know the effect. So with 2, I predicted better than the step size 8. So for cryptocurrency, I don't know how much data you have to look back to predict the next value. So you have to always check with the data. It will vary with the data. For me too, for you, it might be for your crypto past data, it might be thing. Where do you get the crypto past data? Is it available? Then? Okay. Okay. So try these out. Okay. And this is for one column. You're only checking one column crypto. That is not going to work all the time. So you have to think about incorporating multiple inputs. Identify the correlation matrix. Then do that task. Okay. So first think what are the other data correlates with the cryptocurrency. Definitely the political situation. Right. So yeah, try it out. If you have any doubt, let me know. There are many people trying to build some models, but the issue is the unpredictable scenarios. That's the issue. You cannot guarantee certain stuff. Anyway, right? So that's fine. All right. So now what I want to tell is, yeah, week of next week, election. I don't think I can come here. I don't know the scenario. So we cancel it. Okay. And week after that, we'll come and meet and we'll do it. And 2 more weeks are there. Only next week, music, that is very simple. Like it's not a big deal. So already you know the technique. So if I want to clone my voice or do something, what you do? You match the spectrogram, right? And scale it up to a certain voice and you just play it out. That's all. It's not a big deal. So the technique behind is known. So I will show the codes and everything. We are not going to build any model. We are going to use the available model and we will generate the music or whatever the things that we need. Okay. And after that, the last lecture is going to be industrial application. So I will talk, there is no coding. I'll talk about the researches that I have done and the results that we obtained, the challenges that we have faced and everything. That's the industrial application. With that, yeah, we will conclude the whole 18 weeks. It's a long time, right? Yeah. Okay. So yeah, that's all for today. So we'll meet week after next. Para, like you can coordinate, right? Next week election results are going to be.
Yeah. All right.
Are you going to be? Are you coming to Sri Lanka to vote?
Yeah. Planning.
Oh, really? Okay. Cool. Then we can meet during that time.
Sure. Yeah.
Okay.
All right.
Okay. Any doubts? No? Okay. Now you have the confidence to build a crypto thing. Okay, let's see. If you have anything stuck with it, let me know. Okay. So only thing, the input shape is going to vary for you, because I have only used one thing. If you have multiple columns as an input, you have to do that part also, right? So first, correlation analysis, selection of the better columns, and use that columns as an input, and the output is going to be the crypto value, next crypto value. Input, even I don't know, the day of the week of the month might contribute. I'm not sure. So you have to work on that as well, right? And yeah, think about it. All right, with that, I'll conclude today's lecture. And,